So for this final lesson, we're going to take every technique that we've learned so far to make a pretty cool effect. So let's dive on in. So I'm going to make a geometry node. And so first we're going to create a circle. And I'll show you why very soon. But first we need it to be polygon, and we need to be an open arc. So it's just the edge and not the face that it creates in between it. We'll increase the divisions as well. So if we create a polywire, it's going to create a tube around the circle that we have. I'll increase the radius, not that much, and increase the divisions by a lot. One thing that you'll notice here is that there's an open point, and that's because whenever a circle is created, even though it is a circle, there's points that aren't actually connected, and therefore we need to create a fuse SOP. So what that will do is any points, even though they look like it's one point, sometimes they are on top of each other, and this just makes it so that within a certain radius, those points will collapse into one. So now we don't have that strange edge. So this is a little thick. We don't want it quite that thick. This looks good to me. Also, I want it to be facing up for now. So I'm going to make this orientation ZX plane. So there's a reason that I did this as opposed to just creating a torus, which is essentially the same shape. And the reason for that is I want to create a velocity field that is spinning around this object, and I can't do that unless I have curves, and those curves I can use to, I'll just show you, it's the polyframe, and so this creates normals along the tangent of a curve, and you'll see what I mean. So now we can see that all these normals, instead of facing outward, are facing along the curve. And this is exactly what we need to create that spiral force. And there's really no way to get it with just the torus. You just need one curve in order to do this. And so that's why we did it that way. And so now we can attrib transfer. So we can take the normals that we've created on this curve and transfer it to this polywire. So now all of these normals are going in a circle, and that's great. And now we will do, as we have always done, point wrangle at n equals fit01 rand. I'm just going to do ptnum, gfmin, max. Oh, I'm doing plus. We don't want a plus. We want to multiply. Now we have a random distribution of normal lengths. And again, I want to multiply against all of these as a whole. So then I'll do mult. Perfect. All right, so we have our shape. We have our normals. We'll convert this to velocity. So now we're going to want to emit from this shape. And rather than just emitting along the surface, I'd like to emit in a more controlled way with more more interesting shapes. So we're going to subdivide this. hide my normals. Okay, so first thing, when you subdivide it, it is going to recompute the normals. We don't want that. But the way that this is distributed, I don't think is great, so we're actually going to subdivide before we attribute transfer. I don't know how much of a difference that's going to make, but I like this better. So one thing we can do to help with the distribution of the normals transferred onto the surface is we can resample this circle and just make a lot more. And you can see the less you have, the less you can work with when transferring it onto something with a lot more points. So if we increase this to maybe 250, it's a lot more evenly distributed. All right, now that we have that, we have our subdivide. I think it still needs to be divided a bit more. Gonna do that, perfect. So we are going to create noise again. And again, this is through a point VOP, which I prefer. And now we're going to go in here, do add. Actually, no, we don't even need to do that. We'll just do turbulent noise. We'll take the position. And we just need 0 to 1 values. And I'm going to promote these after I get rid of that. Okay. Again, I don't care about attenuation. Don't really ever use it. It's nice to have, I guess, but I don't use it. So we're going to actually go back in here. You can't promote the noise type. Or at least, no, I guess you can. Let's see. Yeah, great. So I'm going to go to simplex noise, because that's my preferred noise, at least for what we're doing right now. And I'm going to increase the frequency of it so you can see it a little bit better. I'm going to increase the amplitude. And then a fun little trick is, let's say you have a decent noise pattern, but you want to erode into it a little bit. You can do a fit 0 or fit range after the noise pattern. We're going to promote these. And now I can say the lowest value that will be accepted. So I can shave off lower values and just leave the high ones. And it's going to look weird in the viewport because the normals that I have are making the light shine in strange ways. Could just do no lighting information, and then you can have a better look at what you're doing. So this looks pretty good. I want to emit from this noise pattern. And then another thing that I'd like to do is I'd like to vary the noise pattern. So we will go to offset, and we will do at time. And I want it to be going a bit faster than normal, so I'll do 1.5. If I scrub here, we can see this noise pattern is flowing in and out exactly how I want it to. And now we will create a pop network. And so first thing we need to do is we do want to emit from points. And you can see, again, that it starts off with 5,000. That's not a whole lot. We'll up it to 50 for now. I also don't really want to see the guide, so we can turn that off. And so all the points are along the surface, but I want to drive the emission by color. So emission attribute, we are going to change to CD. So now anywhere there's color, the points will be. All right. So one thing I forgot to do is, since we have the normal, this is all still pointing in a pretty uniform way. So we're going to noise it up a bit So we'll do an attribute randomize. Randomize the normal. Go to inside sphere. Plug that into input number 1. And before we start multiplying is when we want to start blending. So we'll do at n equals linear interpolation, so lerp. The current normal. Then we want to get the normal from input 1, so point input 1, the normal, pt num, and then we want to blend between the two with a bias, so we'll create channel float bias. If I create this, now it noises it up a lot. Something like that looks good. That's a good distribution. Alright, so let's see what happens when we start to emit from here. Alright. So it's going to need some work, but it is doing mostly what I've asked it to. So we're going to have to dive into the popnet now. And first we're going to do what we did before with life, because we want to vary it up. So pop wrangle. And we'll do at life equals fit01. And we'll do rand id min max. We'll do 0.15 and 0.8. And then, as I said before, in a pop sim, we don't want it to be a perfect distribution of the lifespan, so we are going to do another ramp. So channel ramp, we're going to name our ramp something real creative, maybe ramp. And then we're going to do a ramp redistributing the ID. So if I create that, let's say we'll do a curve, something like, I don't know, a lot of stuff in the middle range, and then a lot of stuff towards the end range. So we have sort of a good variance here. Alright, so now that we have that, we'll give it, let's see, we'll do some pop force. Let's give it an amplitude of 4, so we can see that it's doing stuff. Pulse length, the amount that the noise sort of moves through, we want that to be 5, so it just moves faster. And let's see, another thing I think we'll want is some drag, so that doesn't all just fly out as fast as it can forever. So we will do a pop drag. Air resistance, let's make it 3. And then we'll use a vex expression. So air resist. So one thing I hadn't mentioned before is that when you're messing with vex within pops, these attributes here, they're just variables. So you don't have to declare them. You just hover over what they are. And in this instance, it says air resist. So you don't have to put an at air resist. You just put air resist. So put air resist times equals n age. And so what will happen is that as it grows older, its air resistance becomes greater. Okay, let's see what happens here. Oh, wow, yeah. So that's looking cool. So another thing that we can do and I'm not going to go too deep into this, but I think it'll make it look a bit more interesting, is in order to vary up the motion of these particles and have them interact with each other a little bit better, I'm going to introduce a pop fluid. And pop fluid, you have to put it on the top of the chain, because while most of these nodes are not order dependent, pop fluid is. And so we just want to make sure that these particles are starting to stick to each other before the noise is applied. So pop fluid, I'm going to put that down. And so I've already played around with a lot of these settings. So I'm just going to put these in. Again, I'm not going to go too deep into how to use the pop fluid, but it's something that you should definitely try out yourself and experiment with, because it really adds a lot of variety to the way that your pop sims can look. It's similar to pop grain, but runs different math over the particles. Going to run these over a lot of neighbors. We want a lot of particles to be involved in this. And max neighbors, let's say 150. So let's see what happens now. So stuff is happening. I can see things starting to sort of clump together, but I think we need more particles in order to truly tell. So let's try that out. So actually, before I run this, I'm going to reduce the velocity so that it doesn't overtake things too much. So in my multiply I had, let's see, I'll just do regular. Just do it at 1. Looks about right. So now I'm going to flipbook this. Let's see what happens. We'll take it from 1001 to 80. Okay, so that's flipbooked. Let's take a peek. All right, that's looking pretty cool. It's giving me these fun little licks that you wouldn't normally get from just pop force. So we have this coming off. Now we want it to move. So we'll have to do a couple things. First, we want to move after the noise. Otherwise it's going to be swimming through noise. So we're going to do a transform. And we're going to move this in the negative x. So let's do negative 5. Cool. And now I want it to be rotating up. I'll do 8. So now that it's rotated or moved from origin, I can rotate at origin. So I don't really have to do much as far as animation except hit rotate. So we're going to be rotating along the Z axis. So, and I'm going to create a key. So I'll just hit Alt click in that channel. And let's say over, let's say 32 frames. I'll move it up. I think, let's look at 90. Wrong way. Let's do negative 90. Perfect. That's exactly what I want. Another thing we'll need to do is in here, since it's going to be moving through space, the point count isn't going to change, and that's pretty important because in order to prevent stepping, we're going to need to do interpolate source. and we'll do forward, and we'll match topology. And this is just a way to, through sub-steps, make sure that none of the points are in that weird striation pattern that I had showed before, and makes it so that we don't really have to go in here in the simulation and up the sub-steps. It interpolates for you before you have to do that, which is pretty nifty. So the next thing we're going to want to do is cache this out. So I'm going to make a new file cache. Name it ring particles. And I want to do it for, let's say, 100 frames. So sit back and relax while this goes. And I'll save to disk. Okay, we've got our sim cached. Let's see what this looks like. Oh, let me stop this. Forgot we need to load from disk, so it doesn't actually sim. Let's take a look again. Oh, and we have to put our viewing flag on it. That would help. Okay, so we got a good idea of what it looks like now. Looks pretty cool. And now we're going to do some things after the fact. So first of all, we're going to want to create a p-scale. Whoop. Of course, it's the same thing we've been doing this whole time. P-scale equals fit 01 rand ID min max. So we'll do a minimum of 0.005 and 0.1. Have a really wide variation between largest and smallest. So next we are going to create some color. So let's do point wrangle. I usually do different operations in different wrangles just so that it's easier to find if you have to dive through your script. And you could just rename these things. So I could say color, scale. To be honest, I don't really do it that much unless I know that I'm going to be passing a set off to someone else. It's a good habit to get into, so it's easier for you to find it later down the road. But if you don't feel like it, well, don't worry about it. Unless, of course, you have to give it to someone else. So, I'm going to give this color. And I want it to be, let's see, we want a vector ramp. So, and we'll name it something like color ramp. And we want to redistribute, can't say that word, redistribute color. And now if I create that ramp, going to make this green, going to make this red, going to make this blue. So we have to change the ramp a bit so that we get a better amount of all the colors. So let's do something like that. I'd used the fit before to call out some of this noise, and in doing so it's sort of changed the distribution, but something like that would probably look pretty cool. Okay. See, now we also want to randomize the normals of this, so we will do attribute randomize. Whoop. And we'll do normal, and you'll see why in a moment. So what I'm going to do is I'm going to take these points and I'm going to copy an object to them, and I'm going to do boxes. And now we got ourselves a bunch of little boxes. So let's just see, before I flip book this, let's get this viewport in a good spot. Alright, something like that. So let's flip book this, see what happens. So I'm going to stop it here. I can already tell one thing is missing that I want it to have. And that is we want it to get smaller as it goes along. So not too hard. We'll just do at p scale times equals -1 minus n age. If we did it the other way around, as it grows older, it would get larger. So since n age is something from 0 to 1, let's say a fourth of its way into its life, it'll be 0.25. So 1 minus 0.25 is a scale of 0.75. And that's why we do 1 minus n age. So let's see what happens now. Alright, let's take a look at this. Oh, it's looking cool. Alright. So, there's really only one more thing that I think that would be interesting to do with this. And so, to see what I'm talking about, first let's just take a quick render of it. So, let's go to a frame down the ways. Alright, so something like this. Let's create a new camera. This will be our circle. We'll go to mantra, make a new one. Circle. We'll do cam 2. Objects, we need just the circle. I guess we'll up this a little bit. And then we also want some lighting. Let's do something like this. We'll give ourselves an area light. Again, I just go up, I hold control, I click that, and it'll create a light in the direction that I'm facing in the viewport. Now let's render circle. Alright, so one thing I can tell right off the bat is that there is lighting. It's not great lighting. So instead of just relying on an area light, I'm going to decrease the exposure significantly, and then I'm just going to create an environment light. And so then that'll fill in some shadows. So all in all, it looks pretty interesting. I'll increase the exposure a bit. Not doing a whole lot. Yeah, something like that. Alright, so we can see that these are all squares on top of squares, intersecting squares. And that could be the effect that you're looking for, but let's say I want this all to sort of blend together into one mesh. Well, we can do that pretty easily. It's going to be expensive though, and by expensive I mean computationally heavy. But it might be the thing that turns this around and makes it look extra special. So I'm going to take VDB from polygons. So if we go here, I've got my cubes, and this is going to create a surface VDB, and then I need to create a convert VDB. And then up here, convert to polygons. So this is definitely not what we want. If we go here and hit render, it's going to be pretty gross, I think. Yeah, we don't want that at all. But that's fine, because we can go to here, and once we decrease the voxel size, things will start to show up a little bit better. So, getting better. Still not what we want. Yeah, you can start to pick out individual cubes, but I really want to be able to see the cubes. This looks a little bit more blobby. Let's say you want something that's half cube, half blob, then you're pretty much there, but I want more cubes. I just want those cubes to look like they're all really just in each other to create one mesh, as opposed to just cubes intersecting each other, if that makes sense. So doing that's gonna have to think about it a little bit. Alright, so there we have it. I can see individual cubes, but the edge sort of flows between them. I like that. I think we could technically take it lower, voxel size, but I think for this I don't think we need to. So one last thing is, we had the color of all these cubes. How do we get that color to be on this mesh? So it's pretty simple. There's a few ways you could do it. You could do an attribute transfer. For this, I'm just going to do this second input here. I can turn on a means of transferring the color directly into the VDB. It just needs to think about it a bit. So here it says transfer surface attributes. So I'm going to do that. Again, it needs to think about it. And there we go. All that color information is now present in the VDB mesh that it's generated. So there's two more things that I wanted to do to take this to final. The first is that in our render, we didn't have any motion blur. There is a velocity attribute down here, and the reason that there is because there's velocity being created in the pop net, and then these boxes are inheriting that velocity. And then since we plugged this into the second input of the convert VDB, it's transferring surface attributes, and one of those attributes is velocity. So we do have that for motion blur. So if we just go to circle, render, And then in sampling, where it says no velocity blur, we have to check that to velocity blur. Also, when you're rendering, you just have to make sure that in your mantra node, you have allow motion blur on. And then another thing that I did is in the environment light, I've added an HDR and changed the exposure, changed the transform of it so that it has a little bit more interesting lighting. Other than that, I think we're pretty much good to go. So if we go to the render, so here's it with the new lighting. I'm going to render this with motion blur now. Okay, so now we can see that there's motion blur in a rotational direction, and it looks pretty neat. So one final thing before we hit render on this is I have a static cam, but this is an animated torus that's going up, and I want a camera to follow that. So I'm just going to make a new cam. And dive in here, and I don't want to be viewing it at one of the more computationally heavy spots, so I'm just going to go to where my torus is. I'm going to go to the end of this animation. I'm going to create some keys here, and then also I'm going to lock the camera so that it follows me whenever I dolly or pan in the viewport. So I'm going to make this go down, and now I'm going to go down with it. So I'm just going to play around with some animation and try to get a good, a good cam that follows the animation. You don't have to watch me do all of it, so I'm going to speed through it real quick. That looks better. Yeah. I like that. Okay. So we got our camera. There's a couple more things that we should do before we actually kick off to render. So the last thing is, since this VDB is computationally heavy, we don't want to have Houdini have to calculate every frame converting these boxes to VDBs. You want to do as little possible computation while sending this off to render. Houdini needs to create an IFD file, which is a scene description file that is used to then render. And if you have things that need to compute during that IFD generation, it creates very large IFDs and they take a long time to generate, and we don't want that. So we want to make sure that we're doing all the computation beforehand. So this means we need another file cache. You can see it's already taking a long time just to think of that frame, so VDB convert. So now I'm going to run this, and we're only going to do 100 frames. So I'm going to kick this off, and it's going to take a little bit, but it'll be a couple seconds for you. So here we go. Okay, so this is cached. Took a little while, but now if I scrub to different frames, it doesn't have to take quite as long to calculate. I am still not loading from disk. Let me do that. Alright, now it should be reading from disk. Now when I click through this, it does take a little bit of time to read, but not nearly as much as if we were just running the VDB convert calculation over and over. So, really everything's set up, so I think we're just going to render. And so before we do that, one thing that I had mentioned before, and I think is good practice, is we want to drop a null at the bottom of our chain to out render, and then I'll put the viewer flag here and put the render flag there, so it doesn't matter where my viewer flag is, it's always going to render at the bottom of the chain. So really now all that's left to do is go to the out context. We need to make sure that our circle has the correct camera. We're gonna go to we're gonna go to sampling. I'm gonna up it to 6 just so it looks a little bit cooler. And then I'm gonna hit go. I will do render frame range. Make sure that it's 1100 frames, and okay. Gonna hit render to disk and background, and we'll check back when this is done. And it's done. And not only is it done, but my computer is so fast that it rendered twice. So let's go take a look at those renders. So first we're going to do image viewer, which is just a built-in way to view images. And we're going to navigate, render. So the first render, I'm not very happy with the lighting or the motion blur. There's a lot of camera motion blur. So if we play this, there's just way too much motion blur, and I'm not super happy with the lighting, at least at the beginning. So I decided I was gonna just render it one more time. So we can take a look at that. So here's the second render. The lighting's a bit more diffuse. It doesn't have any strong camera motion blur in the beginning. And to get rid of it, I just got rid of camera blur entirely. If you go to your camera, I went to a render property. This isn't really something that you need to concern yourself with right now because it's a pretty niche problem. But if you go to edit rendering parameters, you can do xform, and then where it says xform time samples, you just take this and drag it over. And then if you set that to 0, then you don't have camera blur. Usually not a problem at all. You want camera blur. In this instance, I just didn't really want to mess with animating a camera over and over for a simple effect. But something that's fun to know in case you ever need to do that. So that'll be it for this Vex for VFX tutorial. I hope this has helped you learn fast and efficient methods for creating production level VFX, whether you're just starting out or are very familiar with the software and just wanted to learn something new. Houdini is such a robust software that there are hundreds of ways to go about solving a problem, and what I've shown you in this tutorial is how I solve problems on a daily basis. Thanks a lot for taking the time to watch, and hopefully we'll have more content coming to you soon. Have a good one, and stay classy.